Okay, as all of you can see the screen now here, all of you.
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
So today we'll be, as I already told you that as it is a combined class, clear. So we'll be going through a particular important topic that is projectile motion, where a question is expected, because in the last previous semester the students were lucky enough, the other section students, they got a 16 marks question on projectile motion. Clear? So what is actually this particular projectile motion, that is this particular topic we are going to see here. Okay. Now I think I hope most of you know about this particular projectile motion. Okay. Now whenever you might have seen certain instances, for example, you imagine that every one of you is throwing a stone. You're in a playground and you're throwing a stone. That particular stone, when you're throwing it, how actually it is going? See, remember, you're not throwing horizontally or neither you're throwing vertically. Do you understand my question? Neither you're throwing the stone horizontally, okay, or neither you're throwing it vertically. Is this clear? Suppose this is a stone, neither you're throwing it horizontally or neither you're throwing it vertically. You're throwing at a particular angle. When you're throwing at a particular angle, what is happening? That particular stone is following a particular path and finally it is falling on the ground. Yes or no?
Yes, sir.
Yes, sir.
So that particular projectile motion, the definition you can see, which can come for 2 marks. What is projectile motion? It is that motion in which you are throwing a particular object from the earth's surface. Clear? And what is the path actually it is following? That particular projectile. So when I said it is a stone, clear, that stone actually becomes, we term it as projectile. We term it as projectile.
Projectile.
Clear? And when you're throwing from the ground surface, you imagine that you all of you are playing cricket, and I think everyone has played cricket. You try to imagine that when you're fielding, you're throwing the ball near to the bowler or near to the wicket keeper. When you're throwing it, you're picking the ball from the ground surface or not? Yes or no? From the earth surface, you're picking it.
Yes,
Yes,
sir.
sir.
Clear? And when you're throwing the ball, that particular ball is going vertically or horizontally, or is it following a curved path? That particular ball.
So following a
It's
curved
following
path.
Yes.
Parabolic motion.
Yes. It is following a,
Parabolic motion.
yeah, parabolic motion. Now, that particular parabolic motion, it is due to what? And that particular parabolic motion is under the action of gravity only. It is under the action of gravity. And now, any object, whichever you are throwing it at a particular angle, again and again I'm saying, when you're throwing at a particular angle, you're neither throwing horizontally or neither throwing vertically. Okay, throwing horizontally, vertically, that's a different case. When you're throwing at a particular angle, and suppose that angle is theta, okay, and that particular object, whichever you're throwing, that particular object will be termed as projectile. What it is called? Projectile. Or that particle is called as projectile. Or any body which you are actually throwing, that is called as projectile. And you are throwing at a particular angle, and that particular projectile is following a particular curved path, and it is totally due to gravity only. Why actually it is following a curved path? It's totally due to gravity. So this is what actually we are going to learn today about the projectile motion. Okay, and again I'm repeating, when you're throwing a particular particle or any body at a particular angle only, you're throwing at a particular angle, neither you're throwing vertical or neither you're throwing horizontally. Now that particle will trace a particular path. Here I'm drawing, you see it is tracing a particular path. You can see the arrow mark here. This particle is following a particular path, and that path is parabolic in nature. Okay, and you can say this particular path which is traced by the particle is known as the trajectory of the particle. What it is known? Trajectory. Okay.
Trajectory.
That particular path traced by the particle. What is the tracing? All of you know what is tracing?
Yes, sir.
Tracing means you can say it is a kind of imprint. Or, for example, when you're walking on a sand, your footprints are traced on the sand or not? That is what. Clear. So when you're throwing a particular ball or when you're throwing a particular particle at a particular angle, the path that is traced by the particle is curvilinear in nature, or it is following a curved path, and it is known as the trajectory of the particle. Now that particle is called as projectile. Okay, and the path traced by the particle is parabolic. One of the students said. Okay, now you can see here, who is this person? What do we call him?
Snowboarder.
Yeah, snowboarder. Everybody has seen this, a snowboarder. Now you can see the snowboarder from a particular height. You can see here, from this particular height, actually, what is happening? He is doing this surfing. We call it as surfing. So you can see which particular path this particular snowboarder is actually following. He is following a parabolic path, or the trajectory path, which is clear. The example is clear to you.
Yes, sir.
Yes, sir.
Yes, sir.
You can see the next example. Clear. So from this particular slide, what you can see?
Cycle ride, bike riding.
Yeah, bike riding. Here the bike stunt. Clear. He is also following which particular. So you see, the bike rider, actually you can see here from this particular angle. So he should know at what particular angle actually he should project himself, so that he will fall on this particular pavement. Okay. And if that particular angle is not correct, he will fall before this pavement. Got my point? Next is, what is this? You might have seen in the park that the
Mm,
motion of water, or when you're
fountain.
putting, yeah, when you're putting water for your plants, which is which is there in your garden, which is there in your home, that particular water is also coming from the pipe or not? We say it is a nozzle. What we say? It is a nozzle. Now here what I'm trying to say is, when a water is coming from this particular nozzle, the water is also following a which path? A projectile path, you can see. A trajectory motion is taking place, and it is also a parabolic path. Got my point? So these are some of the examples in your day-to-day life also. Maybe after when the teacher goes out of the class, you're throwing chalk piece on each other. That particular chalk piece is also following a trajectory path. You got my point? Now, these are the following
Yes,
assumptions.
sir.
Yeah, these are the following assumptions which are used in projectile motion. Clear? Any more examples you can give which you have seen in your day-to-day life, or practically you have done it? When a footballer is kicking the football, the ball is totally, or maybe from the goalkeeper, he is kicking from the ground surface or not, from the earth surface, and that particular ball is following a
Yes.
projectile motion. Any other example? You're throwing any object from the fourth floor or from the top of the building. Clear? So many examples you can see here. Clear? So the what are the assumptions? These are the four assumptions which are taken into consideration in projectile motion. The first assumption is the effect due to air resistance is negligible. And remember, whenever you're throwing a particular a cricket ball, when you're throwing near a wicket keeper, or I think everybody is fond of cricket. I'm giving you the example of cricket. When you're throwing near a bowler, okay, you cannot say practically it is not possible that air is not present. Air is present everywhere or not. And whenever you're throwing any object, resistance by the air, which is the surrounding air, or the environment which is present in the environment, that resistance from the air is very much compulsory. but we are assuming that air resistance is negligible. What is the second assumption? The effect due to curvature of the earth is also negligible. Now earth, we are assuming that earth is spherical in nature. Actually, practically it is not exactly spherical. If we see, earth is, we cannot say it is, we are assuming earth is spherical, which you might have learned in your school books. Okay, and that effect due to curvature of the earth is also negligible. Then effect, the earth is also rotating or not? That effect also is, we are taking into consideration that effect due to rotation of the earth is also negligible. Last one is the acceleration due to gravity is constant, which is never possible, but practically it is never possible. That means whenever a ball is projected or whenever a particle is projected from a particular point of projection, and finally when it reaches to a particular point, to the destination, the effect of the gravity, we are assuming that the gravity effect on that particular body is constant throughout the motion. Did you get all the four assumptions? All of you? Any
It,
doubts?
no, sir.
Okay. Now you can see one example I have put over here. There is one diagram, and this is we are going to read this particular diagram. Everyone can see here the red dot. Everybody can see the red dot here. Now, what is this red dot?
Yes.
This is the dot where actually the particle is present, and with a certain velocity, with a certain velocity and with a certain angle, we are projecting this body. We are projecting this body, and you can see here this particular black color curve. You can see this particle is going to follow this particular path along this particular arrow mark, this particular particle. And what is the particle here I have taken here? The particle is the football. Okay, so the football is traveling this particular trajectory path, or you can say the curved path, and finally it is reaching to this particular position. There are certain terms here which you'll read in the coming slides. One is R. What is R? Anyone? Horizontal range. R is the horizontal range. What is H here? H is the maximum height. V is the velocity of projection. Theta is the angle of projection. Clear? So, what is any object which is projected in the air is called as a projectile. Now, this red dot, or we can say this particular football, we say it is what? It is a projectile. Any object, whether it may be a football or it may be a cricket ball or it can be a stone or it can be a chalk piece or pen, whenever you are projecting in the air, whenever you are throwing it in the air at a particular angle, that particular object becomes as a projectile. Got my point? Or most of you might have seen the launching of the missile. You might have seen, or the launching of the missile from the ground level, or the launching of the missile from the what you can say this from the air. Clear? From the air, when I'm talking about, the missiles are carried up by this particular fighter aircraft planes. You might have seen when they are launched, how they are, which path they are following, a parabolic path or not, and it is hitting the target. Clear? Now, what is point of projection? Anyone? This red dot. It is point of projection means it is that point where the object is projected in air.
We started.
Okay.
Projection
That
starting.
particular point, yeah, starting point you can say, where the object is projected in air is called as the point of projection. Next is V. Same diagram you see I'm showing, nothing different diagram. Okay, these are same diagrams. First is point of projection. The point at which the object is projected in air is called as point of projection. What is velocity? With what velocity actually you are projecting that particular object in air is called as the velocity of projection. And we will take the velocity of projection as, you can take it as u, you can take it as v, it is up to you. Got my point? With what velocity you are projecting. What is next one? Angular projections. With what angle that particular projectile you are projecting in air, or with what angle, with that particular angle is with respect to horizontal or vertical. You can see the diagram. That particular angle is with respect to horizontal.
Horizontal.
Are you all there? I don't want to waste my time by calling you roll numbers. Okay, just listen carefully. So it is with horizontal. The angle made by the horizontal where the object is projected in air is called as the angle of projection. What is the trajectory? Already I told you. The parabolic path. What it is? The parabolic path which is followed by the projectile in air is called as, we say it as trajectory. Okay. Now what is time of flight? Anyone? Time of flight. That means suppose you're
Starting point to end
yeah,
point.
you're playing cricket and you're the fielder. The ball has come to you, and it has come in
Time take
contact.
to reach the
Yeah,
ground.
it has come in contact with your hand, and you're throwing the ball to the wicket keeper. So the point of release, when you're releasing the ball, cricket ball from your hand, until it reaches near the stumps where the wicket keeper is standing into his gloves, the time taken by the projectile to cover the entire trajectory. Okay, from this particular point, which particular point? From this particular point to this particular point, the total time taken by this particular trajectory or the particle, okay, and it is following this particular trajectory path, and it is called as what? The time of flight. All of you are clear?
Yes, sir. Yes,
Yeah.
sir.
Let me ask you a question here.
Yes, sir.
If what is t is the total time to reach from point A. You see, I'm writing here. I hope everybody can see. If t is the total time to reach from point A to point B, now can you say at this particular point, can you see this particular point? At this particular point, what is the time taken by this particle to reach at this particular point? If the total time is t, very simple. So this will
T
be
by 2.
t
T
by
by
2.
T by
2.
2.
Very good. So t by 2. Okay. So this is time of flight. Now what is h here? H is a maximum height. Maximum height attained by the projectile, or you can say the maximum, it is the maximum vertical distance traveled by the projectile. Whenever you are throwing a ball, clear? So everywhere you see, let me show you here. Once you have projected the particle from here with a certain velocity v and with a particular angle theta. Clear? In some of the books, theta is taken as alpha, capital V is taken as small u, and this is taken as alpha, and this h is taken as r is taken as r, and h is taken as h max, maximum height. So it is up to you. Okay, whatever you follow. Now here you can see this particle is following this particular trajectory path or not. If you want to find out
Yes,
at this,
sir.
now this particle is going to this particular point, it is also going to this particular point, it is also going to this particular point. Now at this particular point, if you calculate what is the vertical distance, at this particular point you can see what is the vertical distance, at this particular point what is the vertical distance, what is the difference here? You see the vertical distance is going on increasing or not? It is going on increasing, you can see.
Yes, sir.
Okay, but
Yes, sir.
at a particular point, after reaching a particular point, again the vertical distance is going on decreasing, and finally what is happening? The vertical distance becomes zero when it reaches or when it lands here. Okay, so the point where there is a maximum vertical distance traveled by that particular body or the projectile from the which level? This is called which level? From the ground level during its motion.
Ground level.
Yeah, during its motion is called as H max. Any doubts here? Maximum height.
No, sir.
Next is horizontal range. Everybody knows this. Clear? Now you're throwing this particular any ball or any particle from point A, from point A to point B. Okay. So ultimately, when this particular particle or football reaches from here to here, if you calculate the horizontal distance, that is called as the horizontal range. Or you can say, what is horizontal range of a projectile? It is the horizontal distance traveled by the projectile during its entire motion. Now you are not at all calculating the curved motion, what is the path. You're calculating what is the horizontal distance from point A to point B. That horizontal distance is traveled by the projectile during the entire motion. Okay, or during the entire projectile motion is called as the horizontal range, which is designated as a capital R. Understood? All of you understood?
Yes, sir.
Hmm. Okay. Now here you
Yes,
can see,
sir.
yeah, here you can see one simple diagram, or you can see what are these are two different types of balls. One is of which color? Left side you can see it is yellow color ball, and right side is your pink color ball. Okay. What is
Yes,
the,
sir.
yeah, what is the difference between these two? Both the balls are falling at the same rate. Okay. But here this yellow ball, you can see all of you, this yellow ball is actually how it is fired. I am drawing here, you see the red color line. How these yellow balls are fired? Horizontally. They are fired
Followed core path.
horizontally. And here these pink balls, how they are actually dropped? Vertically.
Vertical.
Okay.
Vertically.
So yellow balls are moving horizontally, and now while these yellow balls are falling, they have no effect on its vertical motion. Clear? So what I mean to say is the path traveled by these two bodies. You can try this at your home after the class. You can take a ball or a stone vertically from the top of the building. You go to the top of the building and vertically you simply drop it. That particular stone will follow a vertical path. Got my point? And from the top of the building horizontally, you throw it horizontally, any stone. Okay. Before throwing, see, before throwing, be careful. It should not hit any person. Okay. So whenever you're throwing it
Yes.
horizontally, what is happening to the stone? That particular stone will follow a particular path. You can see here which path it is following. A parabolic path. Is it or not?
Yes, sir.
Yeah. So
Sir.
from here, what we came to know is that horizontal and vertical motions are totally independent of each other. They are not at all depending upon. No doubt, both the balls are falling at the same rate with same velocity, but the path followed by in both the cases they are interdependent to each other. Okay. Now uh, here you can see the ball is kicked from this particular point. From this particular point, it is kicked. Okay. When you're kicking the ball, it is following this particular path. That is the trajectory path, and it is following a projectile motion. Finally, it is landing here. Yeah. This is how we analyze the projectile motion. Now you can see here, let us do some little bit in-depth analysis where you can understand what actually it is. Now at point A, all of you can see this red color dot. You can see all of you. This is called as any body or any body you can take, whichever is available near you. So that body will become as a projectile. What it is called? Projectile. When with a particular velocity, when you're launching it in the air, when you're launching or when at a particular angle, theta with the horizontal, when this particular projectile is launched, it is following a parabolic path. Now you see very carefully, this particular velocity will have two components or not, all of you? This velocity is thrown at a particular angle. It will have two components or not?
Yes, sir.
What are the two components? One is the velocity along x direction, one is the velocity along
And
y direction.
Right
Okay.
y
direction.
direction.
Now, what are the components? All of you know the components. That is v cos theta. This will be v.
Sin.
V cos
This will
Sin
be
cos
theta
theta.
and
v cos theta or not? Same
V
resolution
cos theta.
concept in statics which you have studied. And v of this in a
sin
vertical, it
theta.
will be v
Sin. Sin
v
Sin
theta.
theta.
v sin theta.
Sin theta.
Okay. Now here you can see all of you. Now this particular particle will touch each and every point. You will touch each and every point of this particular path which it has followed or not. Yes or no?
Yes, sir.
Yes, sir.
You see this diagram. When this particle, earlier it was at which position? Earlier this red color dot, the projectile was in this particular position. Now it has
Yes,
reached
sir.
to this particular position. Now this, when it has reached to this particular position, irrespective to y-axis, okay, this is the distance, that particular vertical distance it has traveled or not. That particle
Yes.
has traveled this much vertical distance or not. How much horizontal
Yes, sir.
distance? This much horizontal distance it has traveled. So you see, so what he is trying to say is, if the particle is in the previous one, if the particle is there at in the origin, it is having horizontal component and vertical component. Here also it has horizontal component and vertical component. You can see here v of ix and v of iy. Horizontal component in x direction, horizontal component in y direction. Got it? Now you see here. Here what is happening? It is there at the which point? Maximum. It is there in the maximum height. Here also you do have one horizontal and vertical. So what I am trying to say is how this particular projectile motion analysis is actually taking place. Okay. Again I am showing you here. This is the initial position. Okay. Any doubts?
Okay.
No, sir.
Okay. Clear? And here let us see what is the effect of this particular gravity. Okay. What is the effect of this particular gravity on this particular projectiles? Now when you are firing this particular projectile from this particular origin, when you are firing it, okay, please see here. From this particular origin when you are firing it, and when it is going to this particular position, the previous diagrams all I have clubbed up in one diagram. Okay. In all these diagrams, what can you see? Anyone? Whatever may be the position of the particle, it has its individual horizontal components or not? Yes or no?
Yes, sir. Yes, sir.
Yes, sir.
Whatever. And individual vertical components are also there, you can see. Okay. Now here anyone can say why minus g is there. And remember one thing, whenever we are solving the problems, while solving the problems, I will say you, whenever a projectile is coming in downward direction, clear? There, why it is coming, why actually it is coming in downward direction, can anyone say? Whenever you are firing, why the projectile is not going in space?
Due to gravitational
Yeah,
force.
due to gravity, it is coming in the downward direction. Clear? So there we will take that particular acceleration as minus g. Where we will take minus g? After this particular position. All of you are clear?
Yes, sir.
Yes,
Yeah.
sir.
When the projectile starts coming down from this particular position, and from here to here, okay, it is going in which direction? It is going in upward direction or not?
Yes, sir.
Yes,
And here again after this position it is going in the downward direction. Clear? So whenever we talk about the projectile, why this particular diagram I have shown is, all these diagrams which I have shown here is, you can see, the basic reason is to say you that projectile motion is a combination of two motions. One is horizontal motion with constant velocity, and the other is vertical motion with constant acceleration. Did you get my point? Remember this. Projectile
yes,
motion
sir.
is a combination of two motions. Horizontal motion with which velocity? Constant velocity.
Constant velocity.
Constant
And
velocity.
vertical motion will be with which with what? With
Constant
Constant
acceleration.
acceleration.
Constant acceleration.
Yeah, what I'm trying to say over here is, everywhere horizontal motion will be due to this particular constant velocity, and but vertical motion is totally related to acceleration due to gravity. You got my point? It is totally related due to acceleration due to gravity. Okay?
Yes, sir.
Yes, sir.
All of you are clear?
Okay.
Yes, sir.
Yes, sir. Yes, sir.
So this is all about some part where I hope everybody understood, and basically I know that you have some basic idea about this particular projectile motion also. Is it? Last time you
Yes,
got
sir.
Yes, sir.
you got very easy problem for 16 marks. Let's hope we'll get this time also we'll get this particular problem. Okay. Please give me some time. Can you see the screen, all of you?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
So whatever you have studied, that is the theoretical part. Okay. Now let us see one by one. Now all of you can see the diagram which I am drawing. Can you see whatever I am drawing?
Mm. Yes, sir.
नो सर दिखाई नहीं दे रहा है
Now
Only plain paper, sir. Only one point.
the
सब
point
पॉइंट ही
is
दिखाई दे रहा है
I have not drawn. So
Okay,
this
sir.
is the particular point. Okay, and this particular point is actually projected at a particular angle. Okay, and that particular angle is we are taking into consideration. That particular angle is with respect to what? With respect to the horizontal. Okay, and we will take that angle as alpha. What is alpha? Angle of projection.
एंगल ऑफ
Right?
प्रोजेक्शन
Yeah, we'll write down later on. And with a certain velocity, we are throwing that particular body in air. Okay, or we say we are projecting it in air. Clear? And with what velocity? That is u. U is what? Velocity of projection. So when you are projecting it, this particular particle will follow a particular path. You can see here. It's following a particular path or not? And finally,
यस सर
it is reaching to
Yes,
a
sir.
particular point. Suppose the point of projection, let us take it as A, and where finally it is landing, you take it as B. Okay, and let me draw here one more vertical line, and this will be your horizontal line. Okay, now what is U here? U is
Velocity.
velocity of projection. What is alpha?
Projection. Angle of projection.
Angle of projection. Okay, now let us do one thing. What we will do is this particular velocity of projection which we are talking about, okay, or you say this particular particle, the black color dot which you are seeing, it is projected upward at a particular angle alpha. Okay, now let us see, you take any point, you take any particular point. Okay, suppose I'll take a particular point here. Can you see the point here? So why you are taking it here? You can take it any point on this particular path. Got my point? You can take any point. Okay, I have taken this particular point. Okay, so this point is what? This point I have taken as P. Sir, why P? P stands for particle. You can take this P at this particular point, at this particular point, at this particular point, at this particular point, any point you can take it. Now, when this particular point P, ultimately when you are firing at a particular velocity u and particular angle alpha, this particular particle is going from point A, and at some point, after some time, it is reaching at this particular point or not? All of you? Will it reach
Yes,
here?
sir.
Yes. When it reaches to this particular point, let us take this distance. From which axis? This is from which axis? From x-axis.
It's X-axis.
And you know that in graph distance from x-axis, I'll take it as y, and distance from y-axis is taken as x coordinate. All of you know this? Okay. All of you know it or not?
Yes,
X
sir.
coordinate,
Yes,
y
sir.
yes, sir. In graph, x coordinate, y coordinate, you're drawing or not? What is that x coordinate? X coordinate is distance from y axis. Y coordinate is distance from x axis. Okay. Now my question is, what is the horizontal component from this diagram? Now let me take this diagram. Okay. Now what is the horizontal component? Anyone? Just now I told you. What will be the horizontal component of velocity? Anyone? Array, this is u at an angle alpha. What will be the horizontal component?
So U cos alpha.
It will be
U cos alpha.
yeah, u
U
cos
cos
alpha.
alpha.
Then what is the vertical component?
U sin
U sin
alpha.
alpha.
This is do. That means same. Vertical component of velocity is u sine alpha. Is this clear? Now, whatever we are talking about the vertical component of the velocity, which is u sine alpha, it is totally affected by gravity. But the horizontal component of the velocity, which is u cos alpha, will remain constant. Somebody mute. Okay. Horizontal component of the velocity will remain constant. Okay. Now, here, when we are talking about this particular particle which is moving in air along a particular path, and what is the path it is traveling? A to B. That is, it is going from A, it is going to P, it is also touching this, and it is going to point B. Okay. You can see the figure. Clear? Now my question is, let us calculate what is x and what is y, which you are seeing in the diagram. Now, what is x? Clear? Now, you know the equation s is equal to, anyone? Ut plus
Ut plus apple square.
half at square.
Apple square.
Clear?
Yes, sir.
S is equal to ut plus half at square. This one. Now, what is s here? We are calculating what is the distance of this particular particle which have reached at this particular point. What is the distance from the y-axis? That is your x here. So instead of s, I am putting as x. Got my point?
Yes, sir.
Now, just now I told you the horizontal component which I am talking about, x, which is the horizontal component of the velocity, is remaining constant or not? Is it remaining constant or not? In the previous
Yes, sir.
PPT, I have shown you. When it is constant velocity, what will happen to the acceleration? Constant means uniform velocity. What will happen to the acceleration?
Zero.
Zero.
Acceleration is equal to zero.
Zero. So, for this particular, when we are calculating x, so the equation will be s is equal to ut or not?
Yes, sir.
Why? Because a is 0. Sir, why 0? Because the horizontal component is constant. Got it? So, what is s is you have taken as x. What is u here? Horizontal, what is the component u? U
So
cos
U cos
alpha
alpha.
into t. So, this is the equation. X is equal to u cos alpha into t. Understood?
Yes, sir.
Next
Yes,
coming
Yes,
sir.
sir.
next coming to y. Same equation we'll use here. Okay, same equation. What is the velocity here?
U sin alpha.
Very good. U sin alpha into t plus half at square. When I am talking about half at square, vertical component is moving with which acceleration? Sorry, constant acceleration or not? You see, horizontal velocity is constant velocity, uniform velocity. But vertical component, when you are calculating, it is totally due to acceleration due to gravity. Okay, and I told you it will be minus or not? The diagram I have shown you or
Yes,
not?
sir.
Half gt square. Any doubts?
No, sir.
Where we are taking a is equal to minus g. Okay, so these are the two equations. One is x is equal to u cos alpha into t, y is equal to u sin alpha into t minus half gt square. Okay,
Yes, sir.
now
Yes, sir.
this is equation 1 and equation 2. Now all of you see carefully. What is from equation 1? Can I write t is equal to x by u cos alpha? From this equation, can I write t is equal to x by u cos alpha?
Yes, sir.
Yes.
Yes, sir.
Substitute
Yes, sir.
substitute the value of t in equation 2. You see, y is equal to anyone u sin alpha into instead of t x
Into
by
x by u cos alpha,
u cos
u
alpha
cos alpha
minus half g
minus g
x
X
by
by
x
U
by
cos
u
alpha
cos alpha square.
whole square. Why I am saying this is very important. Last time you got this for 6 marks. Okay, and once you got a question for 2 marks, write down the equation of trajectory. Now you see here, u gets cancelled. Clear? So what will be the final equation? X tan alpha
X tan alpha
minus gx square by final equation I'm writing 2u square cos square alpha. All of you are clear? Is it correct?
Yes, sir.
You should remember this. If anybody asks you, still I remember this equation. Y is equal to x tan alpha minus gx square by u square 2u square cos square alpha. Okay. If you remember this particular formula, you can solve any problem. Y is equal to x tan alpha minus gx square by 2u square cos square alpha. So now what is this equation? Okay, so this equation is known as the equation of trajectory. What it is called?
equation of trajectory.
Equation of trajectory. You said no, somebody said equation, that particular trajectory is having a which motion? Parabolic motion or not? For that parabolic motion, this is the equation of trajectory. So what is the equation again? Y is equal to x tan alpha minus gx square by 2u square
minus GX.
by 2u square cos square alpha. Understood?
Yes, sir.
Okay. Clear? Next, let us go to, we have certain terms. Clear? Just now again I'm showing you this. U is what? Velocity of projection. Alpha is what? Angle of projection. Okay. In the same diagram, this is the point where the particle is attaining the maximum height or not.
Yes, sir.
This particle will
Yes,
attain
sir.
the maximum height. So that is called as H max. What is H max? Maximum height attained by the particle. Okay. Now A to B, horizontally the distance, if you calculate, that horizontal distance from A to B is called as R. What is R? Horizontal
Horizontal
range.
range.
Okay. Now capital T, already I told you, What is T? The total time of flight. The total time taken by the projectile from point to go from point A to point B. So let us find out all these formulas for the parameters which I have discussed. Clear? What is the first one? H max. What is H max? Maximum height attained by the projectile. Clear? The same diagram. Is it necessary to show you all the time this diagram? This diagram all of you understood or not?
Yes, sir.
Horizontal component is
Yes, sir.
u cos alpha. Vertical component of velocity is u sin alpha. Okay. You remember just now I am asking you. Now, when we are talking about H max, all of you see here, when you are talking about H max, I am drawing the rough diagram. This is the diagram which I have drawn from A to B, and the particle which is attaining the maximum height, it is called as H max. Now my question is, what is the initial velocity in vertical direction? Yes, anyone? What is the initial velocity in vertical direction?
0.
Zero.
Initial
Zero.
velocity in vertical direction. At this particular point I am talking. At this particular point. Again you are forgetting.
Maximum.
Yes, at
Sir,
maximum
maximum
point.
city.
Yes, initial velocity is how much? Initial velocity in which direction? In vertical direction. In vertical direction it will be u
U sin theta.
sin alpha. U sin alpha. Now my question is, what is the final velocity in vertical direction?
Final
What is the
velocity
final
also 0.
velocity? Final velocity will be 0. All of you are
After
clear?
reaching 0.
Yeah.
Yes, sir.
Here I am saying after reaching the maximum point, the final velocity becomes 0 or not? It goes to 0, again it comes down with certain velocity. Okay.
Yes, sir.
So here we are going to use this particular expression. All of you know this, v square minus u square is equal to
2s.
2s. What is the final velocity? 0 square.
0.
What is the initial velocity?
U sin alpha.
U sin alpha
U
whole square.
square.
2 into, yeah. What is A here? Anyone? Just now I told you in one of the diagram. At this particular point, what is A? Minus G or not?
G.
Minus G.
A is minus G or not at this
9.8.
particular point? Below.
Yes, sir.
So 2 into minus G into
Minus
what is
9.8.
S here? H max. Okay. So when you solve this, you'll get H max. Yes. Here you'll get minus gets cancelled both the sides. Is this clear? H max is equal to u square sin square alpha by 2g. This formula you have to remember. If you don't remember the formula, that is the reason why I am doing the derivation. Any doubts? H max is equal to
No.
u square sin square alpha by 2g. Shall we go to the next?
Yes, sir.
Is this clear, all
Yes,
of you?
sir.
Yes, sir.
Okay. I am writing one by one all the formulas. Don't worry. We will write at the end. Clear? So next parameter is H max you have found out. Next parameter is time of flight. How time of flight is designated? Capital T. Okay, what is time of flight? It is the time taken by the projectile from point A to point
Point A to
B.
B.
So it is a total time or not?
B.
It is a
Yes, sir.
total time.
Total
So
time.
yeah, it is a total time. Now, here what I'm trying to say over here is, let us use this particular expression. S is equal to ut plus half at square. Is this clear?
Yes, sir.
Yeah. Now, when that
Yes, sir.
particular particle is traveling from point A to point B, the y coordinate of at any point, which coordinate I'm talking? The y coordinate.
Y coordinate.
Yeah, y coordinate means along y axis. Along y axis, we are seeing we are seeing that at we have seen that particular diagram. Again, I'm showing you. You see here. Sorry. This particular diagram I'm showing you. Can you see here? I'm talking about this particular point, P.
Yes, sir.
This particular point, P. When you're talking about this particular P, this distance, how much you have taken? Y or not? That is distance from x-axis.
Yes, sir.
You have
Y.
taken Y. So S we will consider it as Y. So when you are taking Y, this is the vertical distance or not? Y is the vertical distance. So in vertical direction, what is the velocity? U sine alpha
So U sin alpha.
into T minus half gt square. All of you understood why minus half gt square? Because A is
Yes,
again
sir.
equal to minus g.
minus G.
Clear? Now when the projectile is reaching from which point? From point A to point B. Now you say me at point B, what is the value of y? At point B, what is the value of y? You see what my point is? We are calculating what is the time of flight from point A to point B. This is the particle. This is the particle. It is reaching here. It is reaching here. It is going here. It is going here. It has some distance y. This is also y. This is y. This is y. This is y. Finally, when it reaches here, what is y here?
So 0.
0. Did you get my point?
0.
Y means distance from x-axis. So when it reaches at point B, y will be 0 or not? So why you are putting 0 here? Because total time of flight can be calculated from A and when the particle reaches point B. So it is u sine alpha. When it reaches point B, this t will become the total time of flight minus half gt square. Any doubts?
No, sir.
No, sir.
Small t, why it has converted to capital T, you know now? Because the particle reached from point A to point B. Now from that equation, it is u sine alpha into t. This you take to the other side, it becomes positive. It is half gt square. Is it correct? It is correct or not? So t is equal to,
Yes, sir.
okay, what is t? 1 by 2
So 1 by 2 U sin alpha gt square.
gt square by, sorry, this t also will become capital T, na? Why you are not saying? Okay, yes or no?
Yes, sir.
Yes, sir.
Yes, sir.
You do one thing, instead of doing this
Yes,
from
sir.
this equation, clear, u sine alpha into t is equal to half gt square. T and this t gets cancelled or not? One of the t gets cancelled. Yes or no? So u sine alpha is equal to gt by 2. Is it correct? So t is equal to, is it correct or not? So t is equal to 2u sine alpha by g. So this is the final equation. What is the total time of flight? T is equal to 2u sine alpha by g. Is this clear?
Yes, sir.
Yes, sir.
Yes, sir.
From point A to point B, so T is equal to 2u sine alpha by G. This is one more formula. One more question I'm asking. Time to reach, you have already said this. Time to reach the highest point. Time to reach the highest point. Clear? So this is the highest point or not?
Yes, sir.
At highest point, what it is called? H max.
Which
Okay.
makes
So time to reach the highest point, how do you find?
T by 2.
Yes, it is T by 2.
T by 2.
That is time of flight by 2. So what is the formula? U sine alpha by
U
G or
sine.
not? Are 2 gets cancelled.
Yes, sir.
So time to reach the highest point, what is the formula? Time to reach the highest point, you can
U
take it
sine
as
alpha by G.
you can take it as a T dash if you want. So T dash is equal to U sine alpha by G. Okay,
Yes, sir.
this is the time of flight.
Yes, sir.
Next, one more is R. What is R?
Horizontal.
The horizontal range.
Horizontal range. Okay, so let us see how to find the horizontal range. Horizontal range, what is the definition? Again, same diagram, again and again I'm drawing this. Point A to point B. This horizontal distance, when you calculate, is called as the horizontal range. Okay, so it is the horizontal distance between the point of projection. Which is the point of projection? A is the point of projection. And where again the projectile, it is following this particular path, finally it strikes the ground at point B or not? So from A to B, what is the horizontal distance? That is called as the horizontal range. Okay, horizontal range means the distance between A and B, or you can say length AB. Length AB. Okay. Now you give me one question. You answer my question. When you are finding out this particular length, clear? In this, you try to say me. We will use this particular equation, that is S is equal to ut plus half at square. Okay, S is equal to ut plus half at square. You are using it. Now during this particular horizontal range of the particle, when you are calculating, okay, what will be this acceleration due to gravity? Will there be any effect? When you are calculating the horizontal range along this particular distance, will there be any effect of the gravity? Effect of the gravity will be there. When the effect of the gravity will be there? When the body is going in this particular direction. Okay, so the effect on the gravity will be zero or not? Yes or no?
Yes, sir.
Yes, sir.
S is
Yes,
equal to
sir.
ut. What is
Yes.
What is S here? Horizontal range. Okay,
R.
what is the horizontal component of the velocity? U cos alpha.
But
What is the total
U
time?
cos alpha.
What is the total time from A to B? It is capital T.
T.
Okay, capital
Okay.
T or not? So R is equal to
Yes.
U cos alpha into, what is the formula for T? Just now you have seen
2U sine alpha by G.
2u
Divided by
sine
G.
alpha by G. Okay, so we'll see here 2u square sine alpha cos alpha by G. Clear? Now, what is 2 sine alpha into cos alpha? What is the 2 sine
Sine to the
alpha
formula.
into cos
Sine
alpha?
to the formula.
Sine 2 alpha. So this is the formula for R. What is the formula for R? U square sine 2 alpha by G. Understood? U square,
Yes, sir.
Yes, sir.
U square sine 2 alpha by G.
G.
Is this clear?
Yes, sir.
Yes, sir.
Next part is very important. All of you remember this. Let us find out what is the value of angle of projection for maximum horizontal range. What did I say? What will be the value of angle of projection for maximum horizontal range? This may be a 2 marks question or 6 marks question. Just now we have said what is the formula for horizontal range? U square sine 2 alpha by G.
G.
Okay. When R will be maximum, clear? What do you mean by R max? That means horizontal range is maximum. If you want to throw any particle to the highest distance, you should know at what angle you should throw it so that it will go to the highest distance. Horizontal range I'm talking about. You want to throw a particle. Now let me ask you one question, simple question. Two persons, today you can do the experiment with you or your brother, you're there in your home, or maybe you and your friend. Okay, both of you carry same type of equal weight of stone and both of you throw at the same time. What is the guarantee that both the stones will reach at the will strike at the same point? Are you getting my point? So the distance traveled by both the persons, both of you, will be same or different?
Maybe different.
Sir, it's different.
May be different. When it will be same? If you throw at same angle. You try. If you throw at same angle, the horizontal range will be same. Yes or no?
Yes, sir.
But if you're
Yes,
throwing
sir.
at different angles, okay. So one person will throw more distance, the other person will throw less distance. If you know what is the exact angle where you can throw any particle to the maximum horizontal range, then it will be very easy. Okay. So you remember one thing. You have seen a firefighter.
Yes, sir.
He
Yes,
he
sir.
Yes,
he
sir.
yeah, he is throwing water whenever a building is in fire or any factory is in fire. He's throwing the water or not from the nozzle, from a big pipe. So he should also know the angle, exactly what angle that particular water will go through the window or will reach there. Okay. Or whenever a war is taking place, you'll see that any missile is going from a far distance. They should know the angle, exactly at what angle if I fire it will go and hit the target. Yes or no? So that particular angle is nothing but alpha. Clear? And if you want to throw any object to the maximum distance, you should know what is that particular maximum angle. So that is why I have taken R max into consideration. All of you are clear? So when you are taking R max as consideration, if R horizontal range is maximum, so if sine 2 alpha is maximum, then only R max will be maximum or not? Yes or no? If sine 2 alpha is maximum, then only it is possible or
Yes,
not?
sir.
So sine 2 alpha maximum means
Yes, sir.
sine 2 alpha maximum means sine 2 alpha is equal to 1. Okay.
One.
So
One.
sine 2 alpha, what is the value of sine 90? 1 or not? So instead of 1, I have taken
Yes,
sine
sir.
90. So both the sides it gets cancelled. 2 alpha is equal to 90 degree. What is alpha?
Student.
45,
But
45, 45 degree.
always remember that if I throw any object at 45-degree angle exactly, then you can go to the maximum range. Understood?
Yes, sir.
Hmm.
Yes, sir.
So,
Yes, sir.
so alpha is 45. Now let us find what is the formula for R max. R max is equal to U square sine 2 alpha by G. Okay. At R max, alpha is what? At R max, alpha is what?
So
How much?
45.
45-degree.
45.
So U square sine 45 into 2, sine 90 by G. Sine 90 is 1. What is the formula for R max?
U square by G.
U square by G. So these are the different formulas by virtue of which you are going to solve the problems. Okay. Is this clear?
Yes,
Yes.
sir.
Now, before winding up the class, so what are the different things which you have learned today? You can take a screenshot at the end. What are the formulas you have to remember in this so that you can solve any question? And one question is guaranteed from here. Okay, if you're lucky enough, you may get 1 to 16 marks question. Y is equal to x, yes, anyone? Y is equal to x tan alpha minus gx square by 2u square cos square alpha. This is one formula. Next formula is, anyone remember? H max u square sine square alpha by 2g. Okay. What is the time of flight? 2u sine alpha by g. Are you all there?
G.
Yeah. What is T dash?
Yes,
Yes,
sir.
sir. Yes, sir.
T dash means time taken to reach to the,
So U sin alpha by G.
You
yeah,
sign and
time
Papa
taken
G.
to reach the maximum height. Okay. Some distance. So it is u sine alpha by
Sign and Papa G.
g. Okay. Next is horizontal range. R is equal to u square sine 2 alpha by
Into alpha, sign to
sine 2 alpha
alpha.
by g. What is R max? U square by,
U square by G.
U square divided by G.
yeah. At R max, what is the value of alpha?
45.
45.
45 degree.
45.
So these are how many formulas? 6 formulas, which if you have to remember. Any doubts in today's class?
No, sir.
No, sir.
Okay.
Okay.
Maybe today I'll send you 2 problems which are related, 2 or 3 problems which are related to projectile. Please take a note it down. First try to understand and take a note of that. Okay.